So we have a couple of word problems we're going to sort through. All right? So in order to sort through these, we need to read them carefully and try to figure out what they're saying. All right? So it says, in 90% of the last 30 years, the rainfall at Shell Beach has varied no more than 6.5 inches. Think about what no more than means. No more than. So which inequality do you think best fits no more than?
Less than or equal.
I agree. Less than or equal to. When I think of no more than is like I think of Gandalf with the staff. This far, but no
more than.
Right, no more than. Thou shalt not pass. That's right, thou shalt not pass. Alright? So, let's think about it. So 90% of the years, alright, it usually had what? A mean value? What is it? Mean. The average. So if we take the average, which is basically 24 inches, it says it's not going to vary any more than 6.5. So it could be like a plus
Or minus.
6.5, or it could be a what? A minus 6.5. So if let's say we go both directions, right?
Uh-oh.
Let's just do this. We can jot it down, right? We can go this. If we go plus 6.5, we get to what? 30.5. If we go down 6.5, is it like 17.5? All right, so this is kind of like, it could equal this, right? And it could equal that. So if we wanted to like write an inequality, right? We could put 24 is less than or equal to 30.5, but greater than or equal to 17.5. And shoot, you know what we also say? We don't know what it is. We could say x is somewhere in between it. So we just kind of, without doing a whole bunch of math, we just kind of built our answer and set builder notation of the boundaries, right? The boundaries of how much rain was happening in 90% of the last 30 years. But wait. It says, write and solve an absolute value inequality to describe the rainfall in the other 10%. Really? We just solved the what?
Got a part minus what's the total.
We just solved the problem. Actually, it's good though.
Yeah. Now you already know how much.
So think about it this way. Our absolute value inequality for the 90% is we don't know what x is. It's just a rainfall. But if we take away 24, would you agree whatever we have minus 24, which is the average, would have to be less than or equal to 6.5. So this is the 90% rule. So I'm going to write that down. 90% rule. So if it asked us for the absolute value inequality for the 90%, this would be it. But we don't want the 90%. We want the 10%. So let's think about what the 10% would have to be. So the question is this. If the 90% rule is no more than, what would be the 10?
Less than.
No.
Oh, no.
More than. Because the opposite of no more than is more than. If you think with me, if I said you can have no more than 4 slices of pizza, what's the opposite of that? You better have more than 4 slices of pizza. Right? Okay. So we got to do the 10% rule. So here we go. What's going to stay the same? The what? The x minus 24. That's going to stay the same, but except now I'm not doing no more than, which is this symbol. Which symbol am I going to use? No. The greater than. The more than symbol. No more pizza for you.
Keep using both negatives.
I'll have to rewatch the video and see if that's true, or if you're just confused. So, more than 6.5. So all the other years, the 10% of the rain had to be what? Way more than 6.5 on either side of 24. So here's the inequality. Your job is to take this inequality and to do what? With separate it what? Into 2 equations or 2 inequalities that you can solve for. Here's one of the equations that you need to solve, right? X minus 24 has to be greater than 6.5. And the other equation, x minus 24. You could pause me right now and see if you can do it on your own, and then unpause me and see if you got it right. Like if you're watching the video, you could do that. So pretend like you're paused. And now run pause. Could be what? What's the other one?
It could be less than negative.
Perfect. And that will help you guys get, by the way, this is going to be an or statement, not an and statement. Because what do we have to do all the way across the board? We have to what? Add 24 all the way across. All right? We get two answers. X could be greater than 30.5 inches of rain. All right? And X could be less than 17.5 inches of rain. Which if we did, by doing the first one, this one actually makes more sense.
Yeah, I understand.
Exactly. So we have the set of all x values such that x could be less than 17.5 inches of rain. We write the cool word or. X could be greater than 30.5 inches of rain. So this is your set builder notation for the 10% rule. All right, so 10% of the years, either the rain's a lot or the rain is not so much. Because it varied what? It varied more than 6.5 inches. Before it varied no more than 6.5 inches. Okay? All right, we're going to look at the final problem right here. Manufacturing problem. All right, so let's think here. We're dealing with, a can of soup. So let's think of Campbell's soup, right? Straw little can. What's your favorite soup? If you had to like buy a can of soup today, what would you buy? Free advertising. I guess I should spell it incorrectly for copyright rules. I don't know, just put one L. I'm misspelling Campbell's, so technically I'm not really advertising Campbell's. All right, but I love me some New England clam chowder. If you don't like it, that's fine. I'm not going to eat it. But I like clam chowder. I'll put clam. All right, so if I buy a can of soup and it tells me that there's 14.5 fluid ounces, what am I expecting to find in there?
14.5.
That's right. I want this sucker to be 14.5 fluid ounces. By the way, what did I tell you about that Snickers bar that ticked me off?
Oh, they lowered it.
They lowered the ounces but still charged the same price. By the way, we know you Snickers. You used to be over 2 ounces and now you're 1.87 ounces, I think. Charging us the same price for less product.
They're going to see this video on retail.
I'm telling you. So, a company's guidelines calls for each can of soup produced not to vary from its stated volume by what? By more than 0.08 ounces. So, what is basically by more than means by no more than. All right, so we're going to say that's got to be less than or equal to 0.08. So it could be off a little bit, right? But not a lot, just by 0.08. 8/100ths of an ounce. 8/100ths. So we have to write an absolute value inequality. We know it's going to be less than or equal to 0.08. So let's think about how we would write that. How do we write the other one? The other one that we wrote, remember the 90% rule? We did x minus 24 was less than or equal to 6.5, which this particular rule, very similar, right? So I'm going to say x, that's basically what? That's the amount of ounces that is going into the can. The can. Correct. What are we going to do? We're going to take away, what's the actual amount we want? 14.5. Technically, what would I like x to be every single time? Well, I want this to be 0 probably. Or if it's slightly more, it's okay. If they give me a little extra, that's fine. I just want it to be less, okay? All right, so here's our, by the way, this right here, that's your absolute value inequality. Right there. Is this going to be an and statement or an or statement? What was our other one? Our other one was a... two inequalities that you can solve independently of each other and get two different results. Oh, I forgot how to do this one. You guys remember how to do this one over here? Yep.
Greater than or equal to -0.2.
I'm so glad you remembered this. I totally forgot there. Glad you remembered. So now, go ahead and separate those guys and solve them independently and see if on your own you can write it in set builder notation. And we'll come back after this commercial break. All right, this is going to be so easy a caveman can do this. All right, welcome back to the commercial break, folks. All right, so what did you do all the way across the board? Math. Yes.
14.5.
We added 14.5 all the way across the board. All right, so here we have an x. That zeroes out, right? Is less than or equal to 14.58. That's actually kind of what I want them to actually put into the can. Maybe make it like an extra little bite, maybe small. Maybe I get the actual amount where I'm scraping it out of the can. All right, and then this zeroes out. We're left with x is greater than or equal to 14.42. All right, this is an and statement, correct? So we have to say the set of all ounces of soup, notice x, such that the ounces of soup could have a minimum value of something, a maximum value of something, and it could be less than or equal to the maximum, but greater than or equal to the minimum. And the maximum is
14.58.
14.58, and the minimum is?
14.42.
And all you have to do is put the cool little bracket right there to finish your set builder notation. And now you have the inequality up here and the answer in set builder notation down here. Now, if you're one of the few, the proud, and the bored that actually watch this video, you will get the answer right. You won't believe, by the way, students, you will not believe how many people do not get this answer right, even though it's going to be on the web in approximately 30 minutes. I'll be grading papers, and I'll guarantee you, students will have this one blank because they said I didn't go over it in class. But did you think I told them it was going to be on the web? Absolutely. Well, for those of you who are watching this, you probably stopped watching this probably 30 seconds ago. So, goodbye.